Welcome, everyone. I appreciate you making it out. I guess the rain has stopped, but earlier I was a little bit worried about that. My name, you can't hear me? Can you hear me now? Okay, great. My name is Janet Danick, and I'm the coordinator of exhibits for the Park Library, and it is my pleasure this evening to welcome Dr. Andy Mahon and Ms. Avril Harder to share with us their experience and photographs taken while on a research expedition to Antarctica in 2013. If you visited the Baber Room recently, you've seen a sampling of the spectacular imagery they've taken, and you'll be seeing more of that this evening. After the presentation, we invite you to come to the Baber Room to continue the conversation and to have light refreshments. Dr. Andy Mahon is an assistant professor in the Department of Biology at CMU. He joined the faculty in 2011 after completing his BS at Truman State University in Missouri. He followed this with an MS in biology at the University of Alabama, Birmingham. After that, Mahon completed his PhD at Old Dominion University in Virginia and completed 2 postdocs at the Auburn University and 1 at the University of Notre Dame. He's been to Antarctica 4 times to date, the first as an MS student, graduate student at UAB in 2000. He went back in 2006 as a postdoc at Auburn University. Most recently, he led 2 expeditions while on staff at CMU, one in December of 2012 through February 2013, and the second from November through December 2013. His research includes work in molecular ecology, phylogeography, conservation genetics, and evolutionary biology, focusing on using genetic tools to answer important questions in these fields. He'll address these things tonight as part of this discussion. Ms. Avril Harder is an MS graduate student in the Department of Biology at CMU, completing her research in the Mahon Laboratory. She received her BS degree from Eastern Illinois University, where she participated in undergraduate research projects in the areas of cellular physiology and aquatic ecology. Her research at CMU involves using genetic tools to analyze populations of Antarctic sea spiders and to help find undiscovered species of invertebrates in the Southern Ocean. She participated in the November through December 2013 research cruise to Antarctica, and it was her first trip to the ice. And with no further ado, I hope you'll join me in welcoming these people this evening. Thank you very much.
So the easiest way to do this, what I want to talk about tonight is primarily what it's like to work in Antarctica. How do you get there? What do you do? What it's actually like. I don't really want to talk about the science. Come see a science talk sometime if you're really interested in the hardcore of what genetics and molecular ecology and all that stuff are. That's the boring stuff. This is the fun stuff. I'm going to talk about how we get there, what we do, and all that stuff. Avril's then going to talk about her impressions the first time to the ice, what it's like to get ready, what it's like to live in a bed that's this big, and that kind of stuff after that. If you have questions, shout them out. I don't mind being stopped throughout the talk. That's what I want this to be. I want you guys to have all your questions answered as I'm going through this. And I'm going to show a bunch of pictures tonight. You've seen, I think, 11 or 12 of them over in the Baber Room. Just to let you know, I took 11,000 pictures in the last 2 trips. That's the best, okay? I have more pictures of penguin butts trying to get them jumping through the water than I will ever know what to do with. And there's one penguin in particular that at the time, I'm willing to bet, I had more pictures of that penguin than I had of my daughter, my 2-year-old daughter. My wife's not here, so she didn't hear that, which is fine. Okay, great. Okay, all right. Living and working in Antarctica. So I'm going to go through Antarctica, the environment, why we work there, why it's a special place. Then I'll talk about what the U.S. Science Program, the National Science Foundation, what their role is and where we are and how we get there and what we do as a part of the U.S. Science Program. And then I'll talk about the details about getting there, living there, working there, throwing up on the ship on the way there, throwing up on the ship on the way back, and that kind of stuff. I won't talk about that. Okay, Antarctica is at the bottom of the globe. It's that part that's always left off the map. Whenever you look at a map, it's that thing on the bottom. In comparison to the size of the United States, think about it, add Alaska in, add Hawaii in. It's about the same size in general in terms of landmass, in terms of area. It's isolated. It's the southernmost continent. We know it's isolated primarily. There's a whole bunch of things that make it unique, and it's this isolation that does that. The Antarctic Circumpolar Current and the Antarctic Front isolates it by both temperature and current. There is more water going between South America and the Antarctic Peninsula. I think the term is, it's 130 sverdrups. A sverdrup is equal to the volume of water pumped by all of the rivers in the world in a given period of time. So the amount of water that flows through here in a day is 130 times the volume of water that flows in every global river in the same time period. So the water flowing through there is tremendous, and it happens all the way around the current. Supposedly somebody did the math, and I believe somewhere right about here it's actually 147 sverdrups. So it picks up some speed over here for some reason. But we know it's additionally isolated because it's really, really deep all the way around. So we're talking a few thousand meters or 10,000 feet deep water all the way around the continent between it and the next landmass. The temperatures go from about 5-6 degrees Celsius water in South America to somewhere about right here where you hit that circumpolar current. You hit what's called the Antarctic Polar Front. And the temperature suddenly goes to 0 to 1 degree Celsius water. You go to bed that first night, it's not bad, it's cold, you're wearing a sweatshirt you on the ship, and all of a sudden you wake up the next morning and it's, holy cow, it's freezing. And you can physically feel going through the front. Okay, so the water gets ice cold, literally and figuratively. And again, 135 times the flow goes through there. Now that point's going to come up again in a little bit when I start talking about getting from here to here. Okay? It's a beautiful place. Everybody thinks of Antarctica, you think of ice. You think of these blue icebergs and glaciers and things like that. One thing that people tend to forget, though, that there's a landmass underneath the continent. Okay? And it's in some places it's 2 to 3 miles thick, pushing down and weighing down like a big heavy weight on top of the continent. It actually makes the continent sink into the center of the Earth a couple hundred extra feet. So the fisheries and the shelves, the continental shelves, are around Antarctica, it's at about 1,000 feet, versus around North America, they're at about 300 feet, 400 feet. So it depresses the continent into the center of the planet. But there is land under there, and there are mountains, just unlike what we would see at the North Pole, where it's literally ice and no land until you hit the bottom of the ocean. Okay, science. What do we do? How do we do it? And all that jazz. Any science program for the United States that's run in Antarctica, you have to go through the United States Antarctic Program, which is funded by the National Science Foundation. Okay? Everything goes through them. Now, there are other agencies around the globe. The British have the British Antarctic Survey. The Germans have the Alfred Wegener Institute that runs research programs down there. The Australians have their own program. All these other countries have their own programs. I'm pretty selfish in saying that we're up there with the best of them. What I'm going to go through now are the places we work down there. Again, South America is somewhere up here about 4 days away by boat. The U.S. runs 3 major research stations on the continent. The first of which is Palmer Station right here. And that's the one I've been to, and that's the one I know the most about. And I'll talk about that one first. Palmer Station houses about 50 people year-round. That's it right there. Okay? It's about 50 people, very close, tight community. It's a former U.S. Navy base. It was a Navy station for a very long time until the Navy gave up its presence in Antarctica. This is Palmer Station on our last cruise. This crab-eater seal decided it didn't want to move, so we had to wait until it moved. The ice was blocking it in. We had to push our way in. Literally, you're looking at the station here. This is the this is the astronomy unit up here. This is the actual housing unit here. The gym, bar, and some other dorms are up there. And trust me, they have an entertainment system to beat all entertainment systems. When you're stuck on the ice and you run out of things to do besides hiking way up here every day, you want movies, you want internet, you want that kind of thing. And they have one of the biggest screen TVs I've seen in a very long time in that room. The ships that we use pull in right here, and this is where cargo is unloaded and loaded. Planes don't come in and out of this station. And there's a reason for that, mostly because they have to land on this glacier up here, and it's a really, really dangerous thing to do. So it's one of the things that I believe Avril's going to talk about is medical clearance and why we have to be so healthy before we even get into the Antarctic ships or programs. Second U.S. station is much farther south. It's right here. It's McMurdo Station. This is the one you've probably seen in pictures, and it's the much more charismatic station. This one can actually hold up to about 2,000 people at a time. Typically, it's somewhere around 1,000 to 1,500. In the off-season, it goes down to about 600 people. It's a small town, and this is the entire station here. Okay, these are fuel depots. This place has a coffee shop, a couple of gyms, 2 or 3 places where you can go to get an adult beverage. If you're walking around, there's probably about 15 different dorm buildings to house all the different people. The walls are paper thin. The internet is extremely slow. And if you're there, honestly, the best impression and the best description I've ever heard of McMurdo Station, it's the back parking lot at a Walmart anywhere in the United States. It's dreary, it's cold, it needs to be updated, and that's one of the major initiatives that the National Science Foundation is going through right now to completely revamp this entire station. These are your dorm buildings, look like old military barracks. Why? Because they are. Okay. This is a fuel tanker coming in to help resupply the station. And I say this, the Walmart as a parking lot as a joke, only because I come to this slide next and realize this is Robert Scott's hut. He overwintered in this thing. If you go in there, and you can take tours of this building, and I got very, very lucky I was able to go in, and you suddenly realize how lucky you are to have those paper-thin walls with space heaters and things like that in these buildings. Because these guys, the early explorers in the late 1800s, early 1900s, that were able to get here first, how they survived, and many didn't, beyond me. So again, there's 2 ways you can get to McMurdo. One of the ways, and the way that I got there when we were able to go in on our longer cruise, our December through February cruise, 2012 to 13, you have to have an icebreaker to get in, mostly because the seas freeze around McMurdo 95% of the year until you can get in there. So the U.S. actually contracts out a Russian icebreaker to plow your way in. A lot of times, and we actually saw one but didn't get any good pictures of it, orcas will follow you in this path all the way into the station. It's amazing. It's incredible. And on our way in, we actually made it to the station a day early, and I'll show you a picture of this in a little bit. If the captain's really nice and you promise to buy him a beer at the bar when you get to McMurdo, he'll pull the ship over. I say this and it sounds funny, but he'll pull the ship over and nose you into the ice and let you have what they call an ice party. And you realize you can get out and play soccer on the ice.
How thick is the ice?
In a lot of places, it's 6-10 feet. And there are pictures, and I'll show you a picture of the ice party that we have in a little bit. It's incredibly thick, and it's thick enough in some places that if you don't come in by ship to get to McMurdo, the more common method, you take very, very, very large airplanes in and out.